Welcome back to Learn Math by Example. In our previous lessons, we laid the groundwork for arithmetic sequences and series, and we've seen many examples related to them. In this video, we're going to continue with 4 more examples so that we can cover as many possible scenarios as we can. By the end, you'll be able to solve these kinds of problems with confidence. Let's start with a classic. Our first example, we're given the sum of 3 consecutive terms of an arithmetic sequence is 30, and their product is 960. Our task is to find these 3 terms. A smart approach for consecutive arithmetic terms is to represent them as a minus d, a, and a plus d. This simplifies our calculations significantly. We can do that because the common difference is d. And if you subtract a minus d from a, you get d. And if you subtract a from a plus d, you still get d. First, let's use the sum information. If we add these terms, the d values cancel out nicely. So we have a minus d plus a plus d is equal to 3a. We know that the sum is 30, so 3a is 30. Dividing by 3, we find out that a is equal to 10, and that's our middle term. Next, we use the product information. The product is a multiplied by a minus d times a plus d, which is equal to 960. Replacing a by 10 into our product equation gives us 10 into 10 minus d into 10 plus d is equal to 960. Now, if you divide by 10, you get 10 minus d into 10 plus d, which is 96. This is the difference of 2 squares. Solving for d squared now, we get d squared is equal to 4. Taking the square root, we find that d is plus or minus 2. So we have 2 possible values for the common difference, which means that we have 2 possible sets of terms. If d is equal to 2, our terms are a minus d, which is 10 minus 2, equal to 8. The middle one is 10. And a plus d, which is the third term, is 12. So the sequence is 8, 10, and 12. Now, if d is equal to minus 2, then our terms will be reversed. A minus d will be 10 minus of minus 2, which is 12. The middle term is still 10. And a plus d will become 10 plus minus 2, which is 8. So the sequence becomes 12, 10, and 8. Both sets are valid arithmetic sequences that satisfy the given conditions. This problem beautifully demonstrates the power of choosing the right representation for your variables. So keep it in mind. For our second example, we're given a sequence defined by the general term un is equal to 5n plus 2. We need to first determine if it is an arithmetic sequence or not. And if it is an arithmetic sequence, we have to calculate the sum of its first 20 terms. To check if a sequence is arithmetic, we look for a constant common difference, d. Let's find the first few terms. Now, replacing n by 1, 2, and 3, we get u1 is equal to 7, u2 equal to 12, and u3 equal to 17. To calculate the difference, we can just subtract u1 from u2, which will give us 12 minus 7 equal to 5. Now, we have to find u3 minus u2 as well. If the answer is 5, then the sequence is arithmetic. If the answer is not 5, then the sequence is not arithmetic. Here, indeed, the answer is 5. Since the difference is constant, d is equal to 5, we can confidently say that this sequence is arithmetic. So, now we can find the first 20 terms of this sequence. Consequently, we have to find S20. Now, looking back at the formula booklet, you'll find out that the sum of an arithmetic sequence has 2 forms. The first one is S of n equal to n over 2 into u1 plus un. The second one is S of n is equal to n over 2 into 2u1 plus n minus 1 times d. Now, since we have all the terms, we can use either of them. Let's find u20 from the given formula and then use the first form. So we have u20 is equal 5 times 20 plus 2, and this will give us 102. Now, replacing these values in the Sn formula, S20 is equal to 20 over 2 into 7 plus 102. This simplifies to 1090. So S20 is equal 1090. Thus, the sum of the first 20 terms is 1090. For our third problem, we're given the sum of n terms of an arithmetic sequence as Sn equal to 20. We also know that the first term u1 is equal to 3 and the nth term un is equal to 39. Our goal is to find the value of n. This problem is a direct application of one of the sum formulas for an arithmetic sequence. From your formula booklet, the most suitable formula here is Sn equal to n over 2 into u1 plus un. This formula directly relates the sum, the number of terms, the first term, and the last term. Now let's substitute our known values into this formula. 210 is equal to n over 2 into 3 plus 39. First, simplify the expression inside the parentheses. This will give you 42. So we have 210 is equal to n over 2 times 42. Thus, when solving this equation, we get n is equal to 10. This tells us that there are 10 terms in this sequence. This example highlights the importance of choosing the most efficient formula from your formula booklet based on the given information. Finally, for our fourth example, we have a more involved problem requiring a system of equations. We are told that the fifth term of an arithmetic sequence is u5 equal to 23, and the sum of the first 10 terms is 260. We need to find the first term and the common difference. This type of problem requires us to set up two equations using the formulas from the formula booklet, and then solve them simultaneously in order to find u1 and d. First, let's use the formula for the nth term of an arithmetic sequence. We know that un is equal to u1 plus n minus 1 times d. Replacing the values that we have, we get 23 is equal to u1 plus 5 minus 1 times d. This will give us 23 is equal to u1 plus 4d. This is our equation 1. Next, we use the formula for the sum of the series. Sn is equal to n over 2 into 2u1 plus n minus 1 times d, since it involves n, u1, and d. Since we know s of 10, we can replace all the values that we already know into the equation. And this will give us 260 is equal 5 into 2u1 plus 9d. Dividing both sides by 5 gives us 52 is equal to 2u1 plus 9d, and this is our second equation. Now we have a system of two linear equations composed of u1 plus 4d is equal to 23 and 2u1 plus 9d is equal to 52. We can solve this system using either substitution or elimination. Now substitution here is easier since u1 has a coefficient of 1 in the first equation. So from equation 1, we can express u1 in terms of d. This will give us u1 is equal to 23 minus 4d. Now substitute u1 in the second equation. This will tell us 2 into 23 minus 4d plus 9d is equal to 52. This is a linear equation with one unknown. Distribute 2 and then combine like terms. This will give us 46 plus d is equal to 52. Now subtracting 46 from both sides, we get d is equal to 6. Replacing now d into the first equation, we get u1 is equal to minus 1. So the first term of the arithmetic series is minus 1 and the common difference is 6. This type of problem is a great test of both your sequence knowledge and your algebraic problem solving skills, often seen in IB exam. And there you have it, 4 more examples to learn more about sequences and series. Mastering these formulas and understanding their applications will give you a strong edge in your IB exams. To get more practice and solidify your understanding, head over to our website, samshub.com. The link is in the description below, along with additional resources. Don't forget, discussion is a crucial part of learning. So if you have any questions or comments about this lesson, feel free to leave them below or on our website. We'll reply to them as soon as possible. Join us for our next lesson where we'll explore more applications on sequences and series.